This video is all about the section 2 simulator of our filtration experiment. Now let's click section 2. Now, this is the walkthrough of the simulator. In this simple conceptual exercise, we'll be filtering liquid albumin or blood plasma. The goal is to filter out each of the primary components as the plasma passes through the filtration system. The plasma is made of several components that will need to be separated, including the following as proteins, sugars, salts, and fats. Continue. Drag and place the filters into the column so that the blood plasma components are completely separated out from the largest to smallest components. Use the reference charts for assistance in arranging the filters. Choose Simulate when you are ready to add the solution through the filters. Now, let's click Reference first. Now, remember from earlier from our overview, the micro filters has the largest pore size, whereas the reverse osmosis filters have the smallest size of pores. Okay, and then we have nano and ultra, wherein ultra is or ultra filtration has this smaller pores than micro, and nano has filter pores that are smaller than ultra and micro. But nanofiltration pores is larger than reverse osmosis. Now we have the size of the components of the solution to be filtered out as protein. Protein is the largest, and then we have water molecules as the smallest. Now let's click done. Now let's simulate. Okay, make sure you have placed all the filters before you run the simulation. Okay, now let's okay, put micro on the top because it has the largest filter pores, followed by ultra, and then nano, and then we have reverse osmosis as the smallest of all. We have reverse osmosis filters as the smallest pores. Let's click simulate. Now we can increase our pressure. Okay. Now remember the correct order of our filtration apparatus. We have the micro as the topmost, followed by ultra, nano, and the bottom part as the reverse osmosis. During the filtration process, you can adjust the pressure to speed up or slow down the process. All right. Now, it looks like the filtration process was unsuccessful. Now, remember, while pressure can be used to speed up the filtration process, too much pressure can lead to clogs or material passing through. Let's try this exercise again. Now, let us reset the sim. Okay. Now we need to adjust the speed. Okay. Now we have continue micro at the top, followed by ultra, and then nano. Then lastly, we have reverse osmosis. Now let us simulate this one and adjust the pressure. We may adjust the pressure too much or a little bit so that it won't clog the filter media. Okay. Now, congratulations, you have successfully filtered out the solution and separated the particles by size. Now, good work. If you would like to replay the exercise and experiment with different filter combinations or pressure settings, choose the Reset Sim option. Otherwise, choose Done to continue. Now, remember, the first trial was unsuccessful because we employed too much pressure. Although the order of the filters are correct, but employing too much pressure will damage the filtration media. Now, we have to reset the pressure on a moderate basis so that our filtration experiment is successful. Now, let us click done. Before we click done, the topmost slot 1 goes to micro, followed by slot 2 as ultra, and then slot 3 as nano, and the bottommost part is reverse osmosis. Okay, this has the largest filter pore size, so this goes to the slot 1. Our micro goes to the slot 1, and then the smallest filter pores as reverse osmosis at slot 4. Let us click done. All right. Now, we already completed our experiment. So the next thing to do is to answer our supplementary questions on our LMS for this filtration virtual experiment. Thank you for watching.